Welcome to part 2 of our Tic-Tac-Toe game with React. Today we're going to be creating algorithms to detect our winner. Hello world, welcome back to the channel. If you're new here, my name is Igor. I'm a software engineer based in Portugal, and on this channel we do coding related stuff like tutorials, challenges and other related topics. So if you're interested in those, please consider subscribing. So last time we started putting together our Tic-Tac-Toe game with React, and we built it with Next.js and Tailwind CSS. If you want to check out part 1 and start your own, you can check the link of the video right here. On that video, we managed to create our 3x3 grid, and we were able to place each player's symbols on the grid on a click. Our plan for today is to finish the entire game. What we're missing is to keep score of the players. Score 1 right here is empty, and score 2 is also empty. We're also going to be drawing an overlay on top of the grid to indicate when a game ends, either by a player winning or the game coming to a draw. And in order to do that, we're going to be developing the algorithm to check for winners. So let's get right into it. Okay, I've put together some slides to try and explain what we're going to be doing. So we have a square which represents the game board that we currently have, our 3x3 grid. And then we're going to have a status overlay of the exact same size, and it is going to be on top of the game board. When it's shown, it's going to cover the entire board, and when the players are playing the game, it's going to be hidden, and we're only going to see the board itself. So let's start by doing that. So all we're going to do right now is, on top of this render board function, which is where we're rendering the board, we're going to create a new function called render status. We'll call it render status overlay. It's going to be inside of the exact same container, so it's going to make it easier for us to develop it. So I'm going to copy the name, going to go to the render board function right here and create a new one just right on top. Okay, for now, we're just going to return div with classes to make it the full width and height of its container, which is going to be the same size as the game board. We're also just going to say it's going to be font bold, the text is going to be large, and it is going to be items on its center. Just to finish it up, I'm going to put a paragraph. It's going to fill in about 93% of its parent size, and we're going to be breaking the sentences by words. I just put a static text here just so we can test it. So if I just save now and go back, we see that we have a div right on top of the game board. Our game board is still beneath it, and now what we want to do is be able to trigger this on or off. So for that, we're going to need a new state. And for the state, we're going to be duplicating what we did right here for the player. I'm going to call it status. And function is going to be set status to update the state. And we're going to leave it initially as an empty string. So now what we can do is go back to the function, and if our status equals an empty string, we're just going to return and not going to render anything because we don't have a status. If we go back, we apparently have the same thing we had before. I'm also gonna add here that instead of saying status here, we are gonna print out the status. So now that container exists, and we are gonna be manipulating the status based on the update function of the game. Right here, we created this update game function on the last video, and currently all it does is change players on each turn. We're also gonna create during this video the if CheckWinner function do something, or if CheckDraw do something else. And inside these functions, we're going to be setting the status to either the winner body or announcing that it is a draw. Okay, so to start, we're going to be declaring the CheckDraw function, which is the easiest and doesn't need any fancy algorithm to be detected. We're going to declare it right up here, const CheckDraw function. And what it's going to do is return that on the current board that we have on state, every row of it has every cell being different of an empty string. And this is how we're going to detect a draw. This means that all of the cells of our board are going to be filled in with strings different than an empty string. So now if we go back here, we can create the if CheckDraw what we're gonna do is set the status to draw. And then we're gonna set a timeout of 2 seconds just to reset the game. So this way we get back to the start when we reach a draw after 2 seconds. Otherwise, we're just gonna have the status on top of the game. We're gonna have to refresh the window to start over. So now when we have the reset game, we currently just set the board to an empty matrix. But now since we have the status and we need to get rid of the status on reset of the game, we're also gonna call here the set status function with an empty string for the default status. Okay, so if we now save this and we go back to test it, let's see, we're gonna place the first symbol, then the other one, this one, cancel that out, cancel this one out, cancel this one out. And now if I click this cell, we should have the status updated. And if we have the status updated, we should have the render of the overlay. And after 2 seconds, our game should be reset. Yeah, so it worked first time. Okay, so let's first try and understand how we're gonna be detecting a winner of the game. So in a tic-tac-toe game, for there to be a winner, we're gonna need the player to have a full set of symbols in a row, a column, in the diagonal, or in the inverse diagonal. So how can we write code to detect this efficiently? Let's take a look. I'm going to introduce a concept of containers. We're going to be starting with the rows container. A container is nothing more than an array which has the size of the grid, which is 3. In each position of the array is going to be the number of symbols that a given player has on this single row. And the index on the array is going to be the same index that it is represented on the matrix. So let's check an example. If a player places his turn in the middle, in terms of rows, he places it on the second row. So on the rows container, we're going to update the middle element, which is the second element, and increment it by 1. Now, if the same player plays on the first row, we're going to do the same thing and update the rows container on the first element and increment it by 1. Same thing if he plays on the second row again. We're going to go to the container and increment it by 1. And the player wins when any of the array values has the value of 3. And this is how we're going to be detecting if we have a winner on our rows. The same thing is going to happen for the columns. I'm going to increment the values of the array when the player plays on a given column. And the same thing is going to happen when any of the elements is a 3, the player has 1. Now, the diagonals are not so straightforward. The diagonal container is going to be exactly the same, still an array of 3 elements, but the way we're going to increment the values has to obey a condition. The values are only incremented when the player plays in either one of these cells and no other. And for us to know that, we need to identify which cell is which. We're going to name all of them. And for us to increment the value, it has to obey a condition where I equals j. So where the row index equals the column index. So let's see an example. If the player plays on the middle cell, 1 equals to 1, so we're going to increment the array on the second column, which is the second element. Same thing for the 0, 0. We're going to increment the 0 index of the container, and then on the 2 and 2. Another difference is that the winning condition for these containers is that all of the elements are equal to 1. And to finish it off, we need to mention the inverse diagonal container. And why does it have to be separate from the other diagonal container? That's because the condition is different. This time, the condition for us to increment the value of the array is that the index of the row plus the index of the column equals the size of the grid minus 1. In this case, it's 3 minus 1, so I plus j needs to be equals to 2. Same thing is going to happen here, and when all of the elements of the array are equal to 1, the player has won on the inverse diagonal. So now that we have clarified all of that, we're going to need to put that into code. So let's take a look at that. So on the update game function, we already created an if for the CheckWinner. So what we have to do now is create the CheckWinner function. Once CheckWinner, we're going to need to define the body. On its body, we're going to check for check for rows, columns, diagonal, and inverse diagonal. So like I mentioned, we're going to be checking on containers, and those containers are going to have a state because they're going to be incremented on different parts of the code. So the first thing we need to do is to actually create the containers. And this is where I want to start taking advantage of TypeScript, because now we're going to start having some complex types that we're going to be manipulating. And with TypeScript, it's going to be easier if we type them correctly. So what I'm going to create is a new interface called player containers. And for each of them, we're going to have an X for the first player. Let's just say it's an array. For the other player, it's going to be an O. Let's also say it is an array, but it's not going to be an array. It's going to be containers. So we're going to define what a container is. So for that, we're going to create a new type, and we're going to call it container. And all it is an array of numbers. Again, we're going to define an interface for the entire containers that exist on the game. Game containers. And what it's going to be is a container for rows. Its type is of container. Same thing for columns, diagonal, and inverse diagonal. So now that we have our types and interfaces, we can come to our player containers and say that this one is going to be of type game containers. Each player has its own, and this one as well. So now that we have all of this, we are ready to create our state. Duplicate this one and call it containers. And we're going to set the containers and type it to be player containers. The player's containers empty. So the same thing that happened before, if we added a new state for the game, we also gonna need to reset that state when the game is reset. So the same thing we did here, we're gonna do a set containers to be an X here. And each of them, we're going to start with the rows, is going to be an array of size 3 in this case, and we're going to fill it with zeros. So if we do the same for the rest of them, this is what we come up with. And now our containers are initialized, so we are ready to update them based on a player clicking on a cell. So let's start with that. Let's close our reset game function right here, and let's start updating our containers at each click. The same thing we did with the board. To dereference it when we're going to manipulate it, we're going to create a new variable called new containers. New containers, it's going to be equal to a spread of the current containers. Missing a dot here. Yep. So what we need to do at each cell click is to update the rows containers, the columns containers, and then check if those together match one of the conditions for either the diagonal or the inverse diagonal. And if so, we also need to update that container. So let's go step by step. So on our new containers for the player, which is currently playing, we're going to say that the rows at the row index that we are currently using, that we extracted from the cell on the previous video, at the extracted row index is going to be equals plus equal to 1. We're going to do the same thing to the columns, but with the call index. And at this point, we should have something like 0, 1, 0, for example. And if we have here 1, 0, 0, it means that the player has played on the fourth cell, which is this one right here, second row on the first column. Okay, to get rid of these errors, we're just gonna do something real quick. We're gonna create a type of dictionary, and we're gonna set the containers to be of type dictionary with the parameter of game containers. So we're gonna have a string. For each of the strings on the right side, it's gonna be a game containers. Now we can delete this interface, and we no longer have the red squiggly lines. I'm going to try and find a better solution for that later. Let's continue with our game. So we have incremented the rows and the columns of the containers for that specific player, and we're going to now implement the check for the diagonals. So if we go back to our presentation, to increment the diagonals container, the first condition is that I equals j, which means row index equals the call index. So let's do that one first. So if the call index equals the row index, we're gonna say that the new containers at player dot diagonal, because it's a condition for diagonal, at the index of the column, it's also going to be equals +1, plus equal 1. Of course, we need to cast alt index to an int. Going back to our presentation, for the inverse diagonal container, the condition is that y plus j equals the size of the grid -1. You can directly put that here. So if, let me put this within parentheses, if row index plus call index equals, let me put a 3 - 1 just to be easier to understand. If this is true, then we are on the inverse diagonal. So I'm going to copy this line right here, and instead of diagonal, I'm going to put inverse diagonal at the same column index. So now our containers are updated every time we click on a cell. So what we do now is set the containers of our component to be these new containers. And now we're done. So if we go back to the update game function, open it up, we're gonna uncomment this, and now we're gonna make if check for winner. We're gonna copy what we pasted here. We're gonna set status to 1, and we're gonna leave it this right here. So now we did the code to update the containers. So on the check for winner function, what we're going to do is check if the containers meet the condition that we need. So for the rows and the columns, it's going to be the same condition. And what we're going to say is, first, let me initialize a variable with the containers of the current player, just for it to be easier to access. Current player containers equal containers at player, and this subject is not undefined. For the rows, going back to the presentation, what we need is that any of the elements of the container is 3. So what we can do is if, we need to do an if for each of them, because if we return directly the condition that we are checking, the other ones will never have the chance to run. So we're going to check each individually and return the result only if it's true, because we named our function CheckWinner. So it's going to return true if it does have a winner and false otherwise. So if condition return true, and the condition is going to be current player containers dot rows dot sum. So sum element of rows value equals 3. If this is true, the current player has won the game. Let's do the same for the columns. I'm gonna paste that right here. Change this for columns because it's exactly the same condition, and it only changes for the diagonals. So if we go back to the diagonals, the winning condition is that all elements of the array equal to 1. So we can do that right now. So current player containers, instead of rows, it's going to be diagonal. Every element equals to 1. And if that's true, a player has won the game on the diagonal. Same thing for the reverse. So inverse diagonal. And this should do it. If none of these ifs goes through, we're just going to return false. And we're going to know that none of them won. So this should be it. This should be the game. We now can test it. The way we can test is on the render status overlay. Currently, if we have an empty status, we're not returning anything. So we're going to let here a message be equal to an empty string. What we're going to say is if status equals draw message equals draw. You're also going to say that we're going to render the message right here instead of the status. We're going to copy the same thing for 1. I believe that's the name we give it. Let me just close this right here. This is draw, this is 1 exactly. So if it is 1, the message is going to be a template string and the value is going to be player right here, 1. So now all we have to do is test if this actually works. So let us go back to our page and start clicking away. So there is a winning condition right now. If I click here, player 2 should win. Player O in this case. So let's click and see what happens. Player X won. So that means we have kind of a racing condition right here. Let me close this up. The condition is this one. When we call update game, the first thing we're doing is to change the player. So if we actually change the player and then check for a winner, for checking for a winner, we are using the current player of the game. It is going to be treating the player of the next turn as the one it's comparing to. So the change of the player should always be the last action. So let's try again. Let's place the X here, O, X, O, X, and now we should have the O player winning. I'm gonna wrap this up in a new function called update player. I'm gonna paste the code right here. And what we're gonna do is, when you check for a winner, we are setting the status to 1. We're gonna keep the player because what's happening is that we are running this, but we are running it to the end. So it's gonna change the player, and when we're gonna render the overlay, it's gonna be already rendering the changed player because it didn't stop. So in the CheckWinner, we shouldn't change the player because in 2 seconds, the reset game is gonna be called. And since the X player always starts, on the reset, we should always have set player to be X. Once we've set the timeout, we're just gonna call return so it doesn't check for any other option. And only at the end of this, now we're gonna call set player. Because if someone won, we don't want to update the player because the reset game is gonna take care of that in 2 seconds. If no one won and no one draw, the set player is always gonna be called. So let's try it again. We're gonna do the same thing in X, O, X, O, and then let's check if we got the right thing. We did. O as 1. Let's try for a diagonal. I'm gonna play it right here, the X here, and another X. So our game is fully functioning. Last thing I want to do is to add points to the player so they know how many they've won. So what we're gonna be doing here to be easy is we're gonna set a new state, which is gonna still be a dictionary. We're gonna call it score. Score and set score. Still going to be a dictionary, but it's going to be for numbers. So a string is going to give me a number. And we actually going to be initializing it. Let's define here const initial score equals, let me just capitalize this, initial score equals x0 and o0. Let's place it right here as a default value. Okay, so what we want to do here now on the render of the scorings is also going to place a function render player score with an X. Same thing right here. And for the bottom one, it's going to be of the O. So let's create this function. Going to declare it right here, const with this name. We are going to receive the player, which is going to be a string. And what we're going to return is a title and the current score of the player. So we're going to start with a fragment to render our content. We're going to add a title, which is going to be player, followed by a space and the player we are trying to render. And finally, the score, which is going to be inside our scores at the player index. So what we need to do is to return this fragment. So we're just going to wrap it in parentheses, going to save it up. Okay, and this is what we have. We have player names and their scores, which are 0 by default. What we now need to do is when we check the winner, actually update the score of the given player. So on our update game, when we do check for a winner, when this is true, we're gonna set the status to 1, and we are gonna call a function called update score. Okay, it's gonna do a couple of things. First, the same thing as before, we're gonna create a new score, which is gonna be destructed from the original score to dereference the variable. Then what we're gonna do is that we're gonna say that the new score, so if we did check for a winner, if that is true, it means that the current player currently on the state of the game is the winner. So what we can do is directly say that the new score as player plus equals 1. Now all we have to do is set score as new score, and we are done. Let's try it out. Let's make a quick game and make our X win. So X has 1 and its score is 1 now. Let's make O win. Place right here, O as 1. And now we have a quick tic-tac-toe game with winners being checked, scores being updated, and a lot of fun to be had. Only thing that was left missing is the timer right here. I'm gonna leave that one for you to make at home. If you want to cheat and copy what I already done, it is gonna be on the GitHub repo on the description below, on the branch called full version. So I hope you enjoyed this tic-tac-toe tutorial. It was a lot of fun to make, and it had a couple of interesting challenges. So let me know in the comments below what you think should be the next project that we build, and I'll do my best to find cool ways of delivering it. As always, if you have any question, feel free to drop them in the comments also, or join our Discord channel, link in the description, and we can help you on any question that you might have. Until the next one, I can only wish you happy coding.